Hey guys, welcome back. Let's quickly learn how to solve the ODEs. So firstly, we are going to be going with second order ODE with constant coefficient. As you know, this has two types, homogeneous and non-homogeneous, and we'll get to each of them one by one. So if we look at a general DE with constant coefficients, that is a0 y double dash plus a1 y dash plus a2 y is equal to fx. So the solution for this is y is equal to cf plus pi. Here cf means complementary function and pi means particular integral. These are also denoted as yc and yp. So basically y is equal to yc plus yp is your solution. And when you're solving a DE, you need to find both of these separately. Now let's start with the first type, which is homogeneous. So your general DE becomes y double dash plus a1y plus a1y dash plus a2y is equal to 0. So here your pi or your yp is always 0. Remember this. So your solution basically becomes y is equal to yc, which means all you need to do is find the cf. So now what is the method to find your cf? How to find cf? So we're going to be following 3 steps. So write these down. Step 1 is we'll write our equation in operator form. So what we'll be doing is we'll be writing d by dx as d. So this is basically a notation. This is not equal to. We're just going to be denoting d by dx as d. So your d2y by dx2 becomes d square. So this equation, this one, how exactly will we write it now? It becomes d2y by dx2 plus a1 dy by dx plus a2y is equal to 0. So this becomes d square y plus a1 dy plus a2y is equal to 0. Now let's take out y as common. Always remember you have to write y on the right side because d is a notation of d by dx. So you cannot write it as y d by dx. This is wrong. It's always going to be dy by dx. This is correct. So always put your y on the right side, not over here. So now what we need to solve, obviously now if this multiplied by this is giving you 0, either this is 0 or y is 0. So this is a trivial solution. When your y is 0, it's called a trivial solution. So this will always be true. So what we need to do is we need to find the non-trivial solution. So we need to solve this. So this brings us to our second step. You're gonna find auxiliary equation, which is extremely simple. You do not need to do anything. Just replace your d by m. So your equation becomes m square plus a1m plus a2 is equal to 0. As you can see, this is a basic quadratic equation which we have been doing for years. It will have two solutions, m1 and m2. Now your third step, this is the most important step. You need to check for the nature of roots. And this can have 3 types, as you may have studied earlier. So let's go over them one by one. So the first type may be that your roots are real and distinct, which means your m1 is equal to, let's write it this way actually. Your first solution is e raised to power m1x, and the second solution is e raised to power m2x. So in this scenario, your CF or your YC becomes C1 e raised to power m1x plus C2 e raised to power m2x. You always have to add a constant coefficient when you are writing your CF. Now your second situation may be if the roots are real and equal. So here your first solution will be e raised to mx, and your second solution will also be e raised to mx. Now we encounter a problem over here because these two are linearly dependent. Two of our solutions can never be linearly dependent. Now what does linearly dependent mean? Linear means degree 1, as you may have studied earlier. So the simplest way to check for this is if you divide two of these solutions, do you get a constant? Yes, we do. This means this is linearly dependent. This will not work for us. So what we do is we change this second solution. We multiply it by x. So our first solution becomes e raised to mx, and second solution becomes x multiplied by e raised to mx, which means your CF will be C1 e raised to mx plus C2 x e raised to mx. Always remember this, two of your solutions can never be linearly dependent. If you encounter linear dependency, always multiply one solution by x. Now your third type of roots is complex roots. As you know, complex roots occur in pairs, which means if the first root is alpha plus I beta, your second root will always be alpha minus I beta. So in this scenario, your CF is equal to e raised to alpha x multiplied by C1 cos beta x plus C2 sin beta x. So these are the three conditions that you need to remember: 1, 2, and 3. The nature of the roots will decide your CF. Let's go ahead and take one example so you understand better. So the question is y double dash plus 3y dash plus 2y is equal to 0. So the first step, we'll write it in operator form. D square plus 3d plus 2 is equal to 0. Sorry, this is d square plus 3d plus 2 multiplied by y is equal to 0. Now we're going to replace d by m. So m square plus 3m plus 2 is equal to 0. Now as you can see, the roots are clearly m plus 1, m plus 2 is equal to 0, which means your roots are m1 is equal to minus 1 and m2 is equal to minus 2. So this is your first scenario, right? Scenario number A that we saw, because the roots are real and distinct. So your CF becomes, CF becomes C1 e raised to minus x plus C2 e raised to minus 2x. This is your solution. This is also the solution to the actual DE as your PI is equal to 0. So this is the solution. Let's look at a second example. Y double dash plus 2y dash plus y is equal to 0. Again, operator form. Now replace d by m. M square plus 2m plus 1 is equal to 0. This is m plus 1 whole square, as you can see. So your roots are m is equal to -1 and -1. In this scenario, what did we do? We took first root as c1 e raised to minus x and the second one as c2 x e raised to minus x. So your solution becomes c1 plus x c2 e raised to minus x. Now let's go with the third example. Y double dash plus 4y is equal to 0. D square plus 4y is equal to 0. Replace d with m. M square plus 4 is equal to 0. So what do you get? M is equal to 2i, m1 is equal to 2i and m2 is equal to minus 2i. So here, as you can see, alpha is equal to 0 as we write alpha plus I beta. So here alpha is equal to 0 and beta is equal to 2. So your CF becomes e raised to 0 c1 cos 2x plus c2 sin 2x. E raised to 0 is 1, so your answer is c1 cos 2x plus c2 sin 2x. So this is the method to find your CF. I will give you guys some examples to do on your own for your own practice, and I will solve them in the next video. So go ahead, these are the questions. Question number 1. So these are the 3 homework questions that you can do. And if you guys have any doubts, leave them in the comment section and I'll answer. Thank you.